You know, we usually picture black holes as these giant cosmic vacuum cleaners, right? Just sucking everything in. But their real power? It's so much weirder than that. Today, we're diving into their most mind-bending trick, how they can literally warp the fabric of time. I know, it sounds like pure sci-fi, doesn't it? The idea that gravity can actually stretch and squeeze time? But here's the crazy part. The answer is a huge, definitive yes. And black holes, they're the most extreme proof we've got.
So, to really get how they pull off this incredible trick, we've got to go back to the very beginning. Let's talk about how they're born, because that's where they get this amazing power to bend the rules of the entire universe.
Okay, so picture this. It all starts with a truly massive star. I mean, huge. And at the end of its life, it can't support its own weight anymore and it just collapses. This creates something with gravity so ridiculously intense that nothing, not even light itself, can get away. And that insane gravity? That's the secret sauce for warping time.
All right, let's really get into this, because this is where reality starts to feel, well, kind of like a dream. We're talking about something called time dilation. And to really wrap our heads around it, let's use a little story. Think about two astronauts and what happens to them near a black hole.
So what is time dilation really? Well, it's this wild idea that time isn't the same for everyone everywhere. It's not universal. It means your clock, the watch on your wrist, your own aging process can literally tick slower than someone else's. And it all depends on how strong the gravity is where you are. Okay, back to our two astronauts. Let's say one of them hangs back in the main ship, super far away from the black hole's pole. For her, time is just normal. It ticks along just like it does for you and me right now. But her partner? He hops in a smaller ship and gets really, really close to the edge of that black hole. And for him, something absolutely mind-boggling starts to happen. Time itself starts to slow way, way down. So let's imagine our brave astronaut spends what feels to him like just a few hours orbiting this absolute monster. You know, he does his work, takes some readings, and then decides to head back to the main ship, probably thinking he'll be back in time for lunch. But when he gets back, he discovers something shocking. For his partner, for everyone else left behind, it hasn't been a few hours. It's been years, maybe even decades. His short trip got stretched into what could be a lifetime for everyone else. That's the unbelievable power of time dilation. So what is actually happening here? I mean, why? How does this even work? Well, the answer means we have to completely rethink what we thought we knew about gravity. It's not just some force that pulls stuff down. Oh no, it's way deeper than that. Okay, try to picture space and time as one single thing, like a giant, stretchy sheet of fabric. We call it space-time. Now, anything with mass, like a planet or a star or even you, creates a little dip in that fabric. And what we call gravity, that's just us rolling along the curves in that fabric. And that leads us to a really simple but totally profound rule. The heavier something is, the deeper the dip it makes in space-time. And here's the kicker. The deeper that dip, the slower time flows within it. A black hole's gravity is so extreme that its dip is basically a bottomless pit. And at the edge of that pit, time slows down to almost a complete standstill. And believe it or not, this isn't just some weird abstract theory for physicists. This is the real deal science that has inspired some of the greatest stories we know and love. It just goes to show you, the real universe is often way stranger than anything we could make up. If you've ever seen the movie Interstellar, you know exactly what I'm talking about. Remember when they land on that water planet orbiting the giant black hole Gargantua? They said every hour they spent there was 7 years back on Earth. Well, guess what? That wasn't just some made-up Hollywood drama. That's the actual physics of time dilation in action. And that scene just nails the core idea. You see, while you can't use a black hole to go back to the past, you can absolutely use one to take a one-way trip to the future. They really are like cosmic time machines. Just, the most powerful and extreme ones the universe has ever cooked up. Okay, so let's zoom out for a second. Forget the movies and the sci-fi stories for a moment. What does all this actually mean for us, for how we see the universe? Well, what black holes really do is force us to question something we take for granted every single day, time itself. Here's the big takeaway, the thing to really remember. Our feeling that time just ticks along at a steady, constant pace, that's just an illusion. It's our local experience. The reality is, time is flexible. It's relative. It gets stretched and squeezed by gravity all over the universe. Black holes are the ultimate proof that the cosmos is so much weirder and frankly more amazing than we can possibly see from our little corner of it. And that leaves us with one last kind of unsettling question. If something we think of as an absolute constant, the flow of time, can actually change depending on where you are, well, what other rules of the universe aren't as solid as we think they are? What else is just a matter of perspective? Something to think about. Thanks for joining me.